Hello, my fabulous sixth graders, and welcome back. It is Miss Lawyer, and if you are working on Learning Target 3.1, the guided practice, you have found the video. So this goes with our Learning Target. I can solve problems using Newton's second law, calculating force, mass, or acceleration. So when we talk about Newton's second law, we know that force is equal to the mass times acceleration. And so this little triangle can help us with determining what is what. So, and our formulas for what is what. So when we have the force that we're looking for, I can multiply my mass and acceleration and find it. Now, if I'm looking for the mass, that would be my force divided by my acceleration. And if I'm looking for acceleration, that would be my force divided by my mass. So there's three different formulas that you need to know. Force equals mass times acceleration. Mass is equal to force divided by acceleration. Acceleration is equal to force divided by mass. So we're going to go ahead and look at this problem here. So Mickey Mouse is riding in a roller coaster with a mass of 200 kilograms, and I am just going to highlight when I see any of those words that we talked about. So mass of 200 kilograms. If the roller coaster accelerates at 4 meters per second squared, and we're looking for the net force. So I'm going to write a column that says what I know. And I know that FMA, and I had kids last year come up with the abbreviation Fargo-Moorhead area to remember the different formulas. Mass times acceleration. Mass equals force divided by acceleration, and acceleration equals, and this is not what I need to be writing here. I had the formula stuck in my head. So now we're going to look at the problem. And our force is what we are looking for. So that's what I ended up highlighting yellow because that's what we're looking for. Our mass is 200 kilograms. And our acceleration is 4 meters per second squared. So now I pick a formula. And that's what I was just doing there. So my formula is going to be F equals mass times acceleration. And then I substitute what I know. So the force I don't know, but I know the mass is 200, and I'm going to multiply that by 4. And so I would get the force is equal to 800 newtons because it's in force. So that would be my answer. So now we're going to look at the next one. Minnie Mouse pushes a shopping cart with a net force of 40 newtons. If the mass of, and I actually was doing this in green, yikes. So net force of 40 newtons, the mass of the cart is 20 kilograms. And so we want to know what the acceleration is. So again, what I know. Again, we have the Fargo-Moorhead area. Do we know the force? Yes, so our force is 40 newtons. Do we know the mass? Yes, it's 20 kilograms. And we're looking for the acceleration. So now we're going to pick our formula. And our formula in this case would be A equals F divided by M. So then we substitute helps if you can spell it right. There we go. Okay, substitute, and we're going to substitute A, we don't know. Our force is 40 newtons divided by 20. So our acceleration is 2 meters per second squared. Would be our correct answer. All right, and then our final question is Mr. Donald Duck. So Donald Duck jumps off a diving board into a pool. If he exerts a force of 500 newtons, and again, I need to make this green because that's what we know. Force of 500 newtons and has an acceleration of 10 meters per second squared. What is his mass is what we are trying to find out. So we're looking for mass. Again, we're going to write what I know. Fargo, Moorhead area. And we're going to get the force is 500 newtons. Our mass we don't know, and our acceleration is 10 meters per second squared. So now we're going to pick a formula. And our formula would be M equals F divided by A. And then we're going to substitute it in. So we're going to say our mass, we don't know. Our force is 500 divided by 10. So our mass is 50 kilograms. Would be our correct answer. So I hope this helps you with learning target 3. I can solve problems using Newton's second law, calculating force, mass, or acceleration. I hope you have a wonderful rest of your day. See y'all back again here very soon. Bye.